And by keeping the talking to a minimum, I
keep
mean
smudging my
absolutely talking.
Is it?
All right, these videos are for you guys. These videos for you guys. So we are on, and this is why I'm not even going to have you work in your Chromebook today because it's almost like kind of distraction. I'm not going to breeze through these. I'm going to make them very detailed, but I want everybody taking notes. Notebook open. This says lesson 1.1 at the top of your notebook. New page, and it says example 4. So when you are taking your quiz, which is open note, and you need help, you can refer to this. You guys ready? Yes? No.
Oh.
You want to read it?
Yeah.
Okay. Let's start. Now, I just want to say something really quick and then you can read it. Remember these types of problems that are more complicated than just the little equations that we need to solve for the variable? These answer the question, why do we need to know this? There are real life situations that require real life math. So, if you're ever wondering, why do we do this? Go to a word problem, look at a real life situation. So we're gonna pay attention, right? Okay, good, we've got our notebooks out, we've got our pencils. Oh, I even see some highlighters. I love it. People are getting serious about note taking. I absolutely love it.
I do it out of
Oh yeah, that's cool. All right, Jacob, go ahead. Read it nice and loud, a little bit slow, so we really can take it in.
Yes, ma'am. 4 friends use an online coupon to get discounts on concert tickets. They spent $108 for the 4 tickets. What was the price of one of the tickets without the discount?
Love it. You should do voiceover work. It's really good. You know what that is? Where you like
Yeah.
on the radio.
Yeah.
Narrator. Come on. What?
Narrator?
Yeah, narrator. You'd be a good narrator. Okay. So let's start identifying the important information from the beginning. Who wants to point something out? Just shout it out. Raise your hand. Go ahead, Bella. What is it? Yeah, 108 is very important. What does 108 represent?
Dollars.
The dollars. It represents the the cost of all of them. We would call that the total, right? Okay. What else is important in this information? Yes.
4 friends.
4 friends, because that tells us how many tickets. Very good. 4 friends means 4 tickets. Did they pay full price for their tickets? No, they had a coupon. Did only some of them use a coupon, or did every
All
ticket?
of them.
Every ticket had a coupon, right? Okay. So they used an online coupon to get a discount. You could underline coupon or discount, doesn't really matter. They spent $108 for all of those 4 tickets. So this and this is kind of the same information. What is the price of one ticket without the discount or before the discount? Do you want to help?
This one.
Shh, this is lesson 1.1, example 4, nice and loud.
So if the discount's $15, you add $15 4 more times, and then you divide it by 4.
Yes, you are thinking logically, which is a real life, real math type of process.
Divide them and add 15 at the end, right?
Yes, I believe only one, if I'm understanding you correctly, I believe only one of those is correct. The first thing I'm gonna do is draw it, because I wanna see what these tickets look like, okay? I like that it's only 4 tickets. Then I only have to draw 4 rectangles. Here are my tickets. Now, the question says, what was the price of a ticket, just one of them, without the discount? So these tickets had a discount, okay? These were cheaper than they should have been. But how can we use the price, which is our variable, right? The original price, because it says what was the price without the discount, that's our variable, that's our missing value. So how can we represent that? Just tell me how I would write that on one of these tickets, using our variable and what we know about. Oh, I'm sorry, the discount isn't given here. It's given in this table right here. Okay, so we have this confirmation, your order online, your online order is complete, and then it's showing the details. A lot of this, we don't need to know. We don't care what the order number is, right? That's something that you're gonna see on a test. You're gonna be like, do I divide 328 by 4? No, that's just the order number, just extra information. We don't really care where they're sitting. We know that they got 4 tickets total. And then we can read this table also. How many tickets? 4. That's our quantity. Quantity means how many or how much. The price of a ticket, we don't know that. That's gonna be our variable. We'll call it P for price, right? We can call it X if we want to. I believe the book calls it P when we move on. The discount is $15. The price of the discount would be $15 4 times. The total that they spent with their discount is 108. So going back, let me just see something. Okay. Going back, how can we show what a ticket price is with the discount just using P as the original price? Yes?
Can you do, like
15 is involved, yes. We have the original price P and the discount 15. So how would I write that on one of these tickets?
15 plus 3, right?
Well, it's a discount.
No.
Switch those. Yes, P, the original price, minus 15 gives you the ticket price. And how many times did they get that discount? 4 times. Let's take a look at the next slide, okay? We'll let P, like we said, represent the original price, because that's what we're looking for. We have 4 tickets that are all worth the original price minus 15. So we have P minus 15 4 times. And we talked about how we can write P minus 15 in parentheses next to the 4 to indicate which operation? That's the property that we're going to use. But the parentheses, making this P minus 15 being next to the 4 indicates what operation?
Sorry.
It's okay. Multiplication, very good. So this is P minus 15 times 4 is the total of what they spent on all 4 tickets, right? Now, I know you guys are still thinking, can we distribute? And what is my answer?
Yes.
Yes, you can. What is the second part of my answer? Yes, you can, but you don't have to, right? Because I find it simpler to get rid of that 4. If it's being multiplied times 4, remember we just said the parentheses with the 4 being next to it indicates that it's being multiplied times 4. So we divide by 4 on both sides. Cancel, cancel. Now we have P minus 15 equals 108 divided by 4. And guys, don't forget, if you want to grab a calculator when you, come in, grab them,
Don't
pass them
mind
around.
me.
No throwing, please.
Thanks.
108 divided by 4, 27. That's not our answer. Scientific calculator. But you could always borrow mine if you want to. There's also an EOC calculator on campus. We good?
Yeah.
So we're not done yet. We have the price minus 15 is 27. Just out of curiosity, what does 27 represent?
X.
Nope, there's no X. What does 27 represent? The price of what? Which tickets?
The discount.
The discounted tickets, very good. 27 represents the discounted tickets. What do we have to do to get the price of the original ticket? Add 15 to both sides. Cancel, and then you have P equals 27 plus 15,
Good.
which is 42. So the price without the discount was 42. A question on your homework might say, and what was the price with the discount? Then you would say, well, it was 27, it's 15 less than that. You guys okay on that one?
And that is for each ticket.
Yes, each ticket originally cost 42, but when they got that coupon, it was $15 off of each one. So each ticket was 27. So to answer their question, the original price for each ticket was 42.
I see now.
But they only paid 27 per ticket. 27 times 4 is what they paid, 108. So we're just kind of going backwards and forwards to just kind of evaluate what we did, make sure it all makes sense. How do you guys feel about that? You want to try one on your own? It's very similar to this question, so it should be okay. Go ahead and try this one.
Eight tickets.
I love what I just heard. They said, hey, now it's 8 tickets. That changes the game a little bit, right? I understand. Thank you. Need help? So, you see how we did the original price minus the discount times 4 because it was 4 tickets, right? This, verifying that 8 P is the original price.
I don't know what
So we're still looking for the original price of the tickets, but these are totally different tickets. They're buying 8 of them this time. And the discount is what? $5. Yep. That's it. Equals what?
I'm using this one.
That's it. You got it. You can use your calculator if you need to. That's it.
Yeah, I got it right.
You got it? Good job.
That's the answer.
Okay, it looks a lot more complicated.
Sheila! I need it.
Girls?
Oh, my calculator.
Oh, are you guys sharing?
Yeah, we're
Sharing is caring. Do it nicely,
It's okay,
please.
we're sharing.
Oh,
Are you having trouble setting it up? Can I see your doctor?
Were you paying attention?
So next time,
okay. Use that box.
when I write the equation, you write the equation, okay? That's why, because I want to point to your notes and say, remember how we set it up. So next time, I need to be that by 8.
You're telling me.
It's 50.
Do you remember how we set it up? It was P, remember we took our tickets. P minus 15, that was in parentheses, and what did we multiply it times? So I want you to write that. We're not working on this try it yet. I want you to write the equation that we used for example 4. 4. It was 4 tickets, so it was 4. Now remember, we're going to use parentheses to indicate multiplication.
I do.
Not X, because X looks like a variable.
I don't know, it's just.
So 4 times, and then we need to have P minus 15.
And then I got it.
Riley, do you need help, or are you going to show me the
What was
answer?
the answer?
Okay. Gracie, you got the answer, right?
Yeah.
Can you check hers and make
Okay.
sure it's correct?
Who? So then.
Riley,
This is mine.
just don't say the answer out loud. Okay, good.
The both sides.
And we said it equal to what?
P equals, what is 52?
No. We said it equal to the total, which was 108. Now this one is a similar situation, but this time you're buying
No.
8 tickets.
No, I'm
The total's 416, and the
Okay, I helped you.
discount is 5. So I want you to try to set up an equation to represent that. You got it?
Pay attention.
Love that. You in trouble or you doing okay?
Lead wood. So yeah.
Okay, so this looks really good. Why don't we distribute it after we cancel? So the beauty of dividing is you cancel and it's gone. So you're still hanging on to it. Once you cancel,
I did the ticket thing.
What you got is.
What do you mean? It's 460 for 18.
Yeah,
And so divide
that's
that
correct.
to get how much?
Hey, what'd you get?
Oh,
My bad.
Excuse me, I'm hearing a lot of chatting. I know you guys are finished and that's awesome, but I don't want you to distract anybody. Oh, you got it, Lathan? Good job. You got it? Anybody else want me to check theirs? That's it. Great job. Oh, I don't know what happened here, Joe.
how do you set up?
Wait, why did we do minus 47 here? The discount's $5.
Yeah, that's the price for one ticket, right? And then subtract the $5.
No. The price, you used X and that's fine. The original price minus the $5 represents your discounted price, and then you multiply that times 8. It looks like most of us got there. Did we get there? Why do you look confused? I think you got there, didn't you? No? Anybody else lost? Want me to go over? Do you want me to just go around the board? Yeah. Okay, let's go around the board real quick. All right, we have the same 4 friends bought tickets for 2 shows, and I heard somebody immediately say, 8 tickets? Yeah, 8 tickets. Now, we're gonna set it up just like, what, go ahead. Yeah. Okay. All right, cool, this is your time to shine. Just, you gotta tell us what you're doing as you're doing it. Okay.
So, and then,
And that's what you have, right, Bella?
so she had 8 tickets,
Okay.
so just like the last one, where she had 4 tickets, you just put 8 in that position. And then the discount was $5, so then you would, just like last time, divide it by 8, and divide it by 8 by each side, which was, what was it? 50. And then it would be P minus 5 equals 52. And then all you would do is add 5, P equals 7.
Whoa.
Slow your roll.
That makes sense.
Oh, because she didn't distribute.
Yeah, because
If
your
you're
hand
doing it
is
on your
yeah,
own,
but it's just longer.
If you don't distribute it, all you have to do is divide.
Yeah, then you
this
just
by
times
both
8.
sides.
And then be negative.
Good job.
I usually distribute, but
If you distribute it and then solve, nothing wrong with it. You just know I prefer to.
it's just longer that way.
Yeah, it takes longer, makes the numbers bigger. Are we good? Oh, did everybody? Thank you so much for those extras. Did you not get some? Anybody not get the quiz practice sheet? I might have given out too many. Everybody got it? Okay, thank you. I'll oh, one of them yours. Anybody needs another copy? I have them up here. All right. We're rocking and rolling.
Oh my gosh.
This is so weird. He's just really proud of you, I guess.
Yeah.
Isn't that nice? Okay. Ready for a crazy problem? I'm proud of us that we're getting more than one example done. Under word problems, we're doing it. Okay.
Oh.
I'm only gonna
Not me.
start this one, okay? We're just gonna start this one. Okay. Oh, yeah, decimals are just numbers, don't judge, okay?
Too bad I just
Who wants, does anybody else have a good narrator
Me.
voice?
Me.
Yeah, Caesar, you wanna try?
Latanya will walk her bike from her house to the bike stop.
I'm so sorry, would you mind starting over? Somebody was talking over the narrator.
Latanya
wasn't you.
will walk her bike from her house to the bike shop, which is 1.5 miles from her house. To get the bike fixed, After getting her bike repaired, she rides home. If the whole errand took an hour, how much time did Latanya spend at the bike shop?
Good job. A word problem like this. This is what it sounds like to me when I see a word problem like this. Johnny bought 5 apples. He walked home 16 miles. He gave some of the apples to his mom. Then he studied for a few hours for his test. What did he have for breakfast the next morning? Doesn't that kind of sound like that? It's like, thanks for all the information, but I have no idea what you're talking about or how to get the answer. And that's okay. That's why we go slow.
I think I know
we
what
gotta
you
break
had for
it.
breakfast the next morning. Some
What was
apples.
it?
Some apples.
Applesauce, right? That's a very good, that's logical thinking. That's good. That's a good guess. But you guys understand what I mean? It's like we're getting all this information. We're like, how does it relate to each other? And how do I figure out the answer? Somebody just tell me, right? So let's look at the important information. Does it matter what her name is?
No.
No, even though it's kind of a cool name. She's walking her bike from her house. I do appreciate the diagram though, right? From her house to the bike shop. Which color is representing the walk to the bike shop?
Red.
Red, very good.
Very good.
They say it is a total of 1.5 miles from her house. So this red line is 1.5 miles. Do you think the distance back will be the same thing?
Yeah.
Yeah, because it's the same route, right? So it's gotta be 1.5 miles. So they're both 1.5 miles, we like that. Miles, whatever it is. So she gets her bike fixed, which means she has to spend a little bit of time at the bike shop, right? After getting her bike repaired, she rides home on her bike because it's now fixed. She had to walk her bike there, which is gonna be slower or faster than riding her bike home? Slower. So she's walking, and this diagram is giving us more information. She walked at a pace of, or rate of 3 miles per hour. Then she stops at the bike shop, fixes it up, goes back the exact same route, same distance, but goes faster. What did she have for breakfast? No, I'm just kidding. So, you guys can laugh, it's okay. Okay.
Wait, so what do you need to do? 1.5.
No, it's super complicated, I'll show you.
Oh, that makes me feel.
No, believe me, it's really hard. It's just more complicated. You're probably thinking about the parts of it. We need to map things out. If the whole errand took 1 hour, so now we know that the time it took her to go all the way to here, get it fixed, then come home took 1 hour. First of all, that's pretty quick. To walk, get it fixed, and to ride home, only 1 hour? Okay. And she had to walk 1.5 miles? Then you, okay, I'm just saying, that guy fixed her bike really fast, right?
I know it's a guy.
It could have been a girl, right? Okay, whoever did it did a great job fixing that bike. So how much time did she spend at the bike shop? How much time? And we can represent that with T, right? Let's move to the next slide so we can start mapping things out. Same question, they're just gonna start mapping things out. This explanation has holes in it, meaning I need to explain how they got from one thing to the next, and it's gonna require a little bit of explanation that we'll get to tomorrow. But first, all I wanna do before class is up is I wanna just agree that all of the time is going to, all of the time together, the time that she spent walking to the shop, the time that she spent at the shop getting her bike fixed by a male or female technician, and the time that she spent biking home has to add up to the total time, right? They gave us the total time. Oh, they gave it to us in the question. They gave us the total time is 1 hour. They also gave us the distance for both walking there and biking home. Remember, the distance was the same, right? They also gave us her speed, her rate. We call that rate, right? 3 miles per hour, 10 miles per hour. Tomorrow, I'm going to talk more about this, but I want to talk about how they and why they would put the time walking to be 1.5 miles per 3 miles per hour. We're going to talk more about that tomorrow, okay? I'm going to allow you guys to pack up quietly.
Oh, where is?
Are we gonna combine 1.5
I'm telling my fast.
We're not, we're actually
I'm flying.
common denominator, so we're gonna multiply everything times 30. It's gonna be crazy. But you were
The one that I gave you?
the right way, right?
What?
Because you did want to divide by 10.
Yeah, I did.
Like, technically, that's
still
part of it, it's just
recording.
because everything's complicated.
With a close
We had your budget. All right, guys.
What did y'all say?
Oh.
Nothing.